What's up, CoderBite? Welcome back to another data structures and algorithms video. I'm Elizabeth, and today I am coming to you live from my parents' basement. Of course, when I moved out, I stole my desk from my bedroom, so this was the best working space for me. So that's cool. I feel like some cool stuff can happen in parents' basements, if you know what I'm saying. So let's make some magic happen today. We are going to be finishing off our two-pointers series with a two-pointers initialized, one at the beginning of an array or a list or whatever, and one at the end. Next week, we're going to cover all about like different kinds of two-pointers problems with fast moving pointers and slow moving pointers. So I'm super excited for that. But for today, let's do this relatively hard two-pointers problem. Let's get into it. Okay, two pointers. As usual, we're going to just go over the pattern really quick, and then we will jump right into the problem. So in many problems involving arrays or linked lists where you need to find a set of elements that fulfill certain constraints, we can use this two pointers pattern to avoid looping over the array or list many times, depending on the problem. Because we're able to process two elements per loop instead of just one, it saves time when we talk about our time complexity of any problem. So some common, sub patterns in this two pointers pattern will be number one, two pointers, each starting one from the beginning and one from the end as they converge towards the middle or whatever. And then there's also, two pointers moving at different speeds. Again, depending on the problem, if one is moving at 1x and the other is moving twice that speed, which, like I said, we're going to start to cover next week. But for this week, we are going to continue to stay within this first sub pattern, which is two pointers, one, moving from the beginning, one moving at the end, from the end, and kind of converging towards the middle, depending on the problem. Okay, so what's this week's problem? Given an array of unsorted numbers, find the length of the smallest subarray that, when sorted, will sort the whole array. So this is kind of difficult to imagine without an example, so let's look at an example. Here we have an array with some numbers, and the key here is that they are unsorted, right? So there's a -1 and a 0 kind of thrown in the middle, etc. So the question is, find the smallest subarray that if we sort that subarray, the whole array will be a sorted array. So in this example, the length of the smallest subarray that will sort the whole array when sorted is 5. Now, what do I mean by that? So let's look at this. So in this example here, we would have to sort all of these numbers. And if we sorted these numbers, the whole array would actually be sorted, right? So let's look at that, right? So that's the sorted subarray, which equals a sorted the full array. We didn't have to sort 7 and 10 because after these are sorted, those are already sorted and they make sense with that first subarray that's now sorted. So that's the problem. So what is our approach? And how are we going to use our two pointers pattern to help us out here? So let's walk through this example, the same example from the first slide. So here's our array, and here are our two pointers. So essentially what we can do here is we can walk the pointers towards the middle until they each, right, if the left pointer, this orange one right here, hits a number that is less than the number before it, that means that, oh, we found something that's out of order. And our right pointer, we're going to do the same thing. We're going to decrement and walk this way. And as soon as we get to a number that is greater than the one before it, after it in the array, that's also indicative that there's something out of order here. So let's watch as that happens. So walking that first pointer up, 1, 3, that's in order, it's fine. Okay, walk it again up. Okay, we finally found 1. 2 is actually less than 3. So that's out of order, and we already know that that's going to be in our window. So let's do the same thing with that right pointer, the blue one. Walk it down, 7 is less than 10, that's fine. Walk it down again, -1 is less than 7, that's fine, that's all sorted. And then we finally get to that 0, and 0 is greater than -1, so that indicates that there's something out of order here. So that's not enough though, right? Because if we only sorted the things that we found to be out of order, which would be 3, 2, 0, and -1, what would happen? Let's watch that. So that's our subarray right now. And if we sorted that, it still wouldn't be in order because -1 is still less than 1. So that isn't enough for this problem. So what can we do instead to somehow figure out, okay, well, I have a subarray, but there are still elements outside of this window that, despite the fact that they're in sorted orders separate from the subarray, once we sort the subarray, it's still not sorted quite yet, right? So what can we do? Let's put those back. So instead of just stopping at that point, we can now find the subarray max and the subarray min. So in this case, the subarray max is 3 and the subarray min is -1. And we can extend the window from each side to include any elements that are on the left side of the array greater than the subarray min, right? Because that means that we still need to include them in the sort to make a fully sorted array. And then we can extend our window to the right to include any elements that are less than, wait a minute, hold on. This is like one of those confusing things. So we extend our window to the left to include things that are greater than the min, and we extend to the right to include things that are less than, that are greater than the max. No, the greater than the max is fine. Less than the max has to be included in the array. Yes, that's correct. Because if it's less than the max in the array, it needs to be before that, whatever that maximum is in the array, because it's less than it, even if it was in sorted order. And, when we code this out, we'll do different problems and we'll kind of walk through different scenarios, because in this case, going to the right, we don't have to, right? Because the max is 3 and all of these are still greater than the max, so we don't have to touch them. It's this side that we have to somehow include this 1 in. So like I said, we'll do this with other test cases when we actually code this out, but let's just like illustrate the actual algorithm here. So what do? We extend the window, right? Asking ourselves, is the element less than, or excuse me, I'm going to do this the whole window, and I'm not even going to refilm this because I'm going to continue to do it. So I hope everyone can bear with me here. We extend the window to the left to include elements that are greater than the subarray min. So 1 is greater than the subarray min, which is -1. So we have to include it in that subarray so that we can sort it along with those other elements. So 1 is now included. And we can do the same thing going to the right. But immediately we see a 7, and 7 is okay. It's not less than the subarray max. It is greater than the subarray max. And because our window is such that we know all the elements to the left and to the right are already sorted. There's also a weird beeping in the basement, basements. Because we know that those are already sorted, we know everything to the right of 7 is greater than 7. So they're all fine, because if 7 is okay, because it's not less than the subarray max, then all of the other ones are also fine. So we can stop at that point. And that's how we get to that length of 5, which is our actual subarray that we have to sort. And I think, oh no, I didn't include it. But if we were to sort those first 5 elements, that is the thing that would ultimately sort all of the elements in the array. So let's summarize the algorithm in words, which is sometimes useful. Initialize a left pointer at the start of the array and the right pointer at the end of the array. Again, this is kind of a repeat of this subpattern of having the 2 pointers at either end and converging with some logic in between. Walk the left pointer forward until you get to an element that is less than its prev. So continue to increment that left pointer until you get something that is out of order. Walk the right pointer backwards until you get to an element that is greater than its prev. So until you get something from the right that's also out of order in terms of, the numbers sorting. Find the maximum and minimum of this subarray. Extend the subarray from the beginning to include any number greater than the minimum of the subarray, because that means if there's if there's an element that is greater than the minimum of the subarray, even if we sort the subarray, it's still going to be out of order because it's greater than the minimum of that subarray. And now extend the subarray from the end to include any number less than the maximum. Same exact logic. And again, I think this is all much clearer when you see different examples, and you'll see how we code this out. But that's kind of the way we're going to approach this, and those are the gotchas, right? You can't just find the subarray out of order, because just because you sort that doesn't mean that it's going to, the whole array is going to be sorted. So without further ado, let's code this baby out. Okay, as per usual, I am in Visual Studio Code Editor, and I just have a blank file here, and I'm going to start us off by putting in some test cases. So let's first define our function. So let's say function find minimum window, yeah, and it's going to take an array. And now that we got that covered, let's add in our test cases. So here I have. So this is the exact array that is from the slides. So, the one that we just did. And we are expecting that to return 5. So now let's do some others. And also, that's not going to work. Hold on. There we go. Okay. And here is another one. And yeah, so let's see. What is that going to return? I think that's going to return 3 because the things that have to be sorted are, 5, 7, and 3. If that's sorted, the whole thing will be sorted. And then we have a console.log find minimum window. This is just going to be an array that is already sorted. So we're expecting return 0 because the length of the array, the length of the subarray that we would have to sort to make the array sorted would be 0. And then I also have one that is find minimum window. In this case, the length of the subarray would be 4 because we'd have to sort the whole thing to make a sorted array. And then I promised that there would be a test case that kind of grew not only from the beginning but also towards the end, but I didn't prepare one. So let's see if I can do that on the fly. Find minimum window, and let's see. So let's do 7, 8, 1, 2, 0, and then let's do 10 and 11. So in this case, again, we are going to have to sort the entire thing. So no, to make it here. So let's say we have to sort, say, 12. So I think in this case, we are again going to have to sort the entire thing because 12 is at the beginning. And even if we sort, this whole bit, we will have to have these before 12. So that would be 0. Well, the length would be 1, 2, 3, 4, 5, 6, 7, 8. So I think that should return 8. We'll see what we get. If the rest are right and it's 8, then it's 8. I didn't prepare this ahead of time, so, bear with me. Okay, so let's start. So what did we say we have to do? We need a left pointer and a right pointer, right? So we can start right off the bat by defining those. Say left pointer equals 0, and let's say our right pointer is going to be the array length minus 1. So that's our pointers. They're at either end of the array. And now what we want to do is here we want to increment the left pointer until we get to an element that is greater than its next number, right? So we want to increment the left pointer until we get to something that when we look ahead 1, it's greater than that, right? So it's greater than the thing that comes after it. And then we also are going to want to decrement the right pointer until we get to an element that is less than its next number. And when I say next number here, I mean its next number as we increment the right pointer. So it will actually be the element that is less than the number that comes before it in the array. But it's the next thing that the pointer would get to as we decrement backwards. So that's, keep that in mind. And then, let's do this and then we'll get to the rest of the algorithm. So like, the other videos, I think I'm just going to use a while loop here because that's kind of like an easy way to do something until there's a condition met. So basically we want to do while the left pointer is, while the array at the left pointer, so the element, is less than the array at the left pointer plus 1. So we want to increment the left pointer until that's not true. So this is increment it while that is true. And the left pointer is less than the array.length minus 1, right? So that would signify that we incremented until we got to the end. We want to do our left pointer plus plus. So that's pretty simple. And then here, it's going to be basically the same, but in reverse. While the array at the right pointer is greater than the array at the right pointer minus 1, right? Because we're going backwards. So while it's still in order, the array at the right pointer is greater than the thing that comes before it in the array. That's a good order. And the right pointer is greater than -1, right? Because we want to go all the way to 0 in this case. We want to decrement. So that's very simple and straightforward. So I think right away, though, if we increment our left pointer and our left pointer gets all the way to the end of the array, then we know that the whole array is sorted, right? And we just want to return 0. We don't want to do anything else. So I think before we even do this, we can check that. We can say that if the left pointer is equal to the array length minus 1, this condition was true the entire way through until we got to the end. We can just return 0 here and call it a day. So that's number 1 off the bat, right? This is, I'm going to just make a comment so it's clear, denotes that the whole array is already sorted. Okay, so now we have our window, right? So now whatever our left pointer is after this while loop and our right pointer is after this while loop, it's the window. It's the subarray of things that are out of order just right off the bat. And now what we have to do is we're going to have to find that min and max and extend the window to include things that, despite the fact that they're in order on their own, won't be in order after we sort that subarray. So we can do something cool here. Let's say or I think we can use a const, right? Subarray equal r.slice. And so what we're going to do here is we're going to take the left pointer, which is going to be the beginning of our window, and our right pointer, which is going to be our right pointer plus 1, because slice is non-inclusive of that second index you give it, and we want to include whatever that right pointer stopped at. So we're going to just say plus 1, which will be the left pointer to the right pointer. And then from there, we can just pass in that subarray to a math.max function and a math.min function. And we can say the const subarray min is going to be the math.min, and then we can just destructure the subarray. So that's basically passing in all of the numbers that are in that subarray. And then we can say our const subarray max is math.max, same thing. So now we have our subarray min and our subarray max, and we can start to extend the window to include things that need to be included. So this is probably going to look similar to the above, right? But let's make a comment just to make sure that this is super clear. So in this while loop, we are going to extend the left pointer, or extend the window to the left to include elements that are greater than the subarray max, because that means that they need to still be sorted with the subarray, because if we sorted the subarray and there are still elements to the left of the subarray that are greater than whatever the elements are in the subarray, they need to still get sorted, right? They need to be put to the end of the subarray. And then we're going to do the same thing, right, to the right. We're going to say extend the window to the right to include elements that are less than the subarray minimum, because that means that those elements need to be at the beginning of the subarray to actually make a sorted array. So let's see what that looks like in code. So we're going to do another while loop here, and this is going to be while the array at that left pointer -1, because remember, now we were incrementing the left pointer, but now we're going to decrement it again, because we're going to extend until something isn't true. So while the left pointer -1 is greater than the subarray max, is greater than the subarray min, right? Because when we, it needs to be, if it's greater than the subarray minimum, it has to be included in the array to make a sorted array. And the left pointer is greater than 0. And in this case, we're saying it's greater than 0 rather than greater than -1 like we did above, because we're always looking one further. So if we got to the left pointer actually being 0, then we would be looking at the array at -1, which doesn't exist. So that's why we do the greater than 0 there instead of greater than -1. We need to decrement the left pointer. So we need to continue to include elements, right? And then down here, we're going to do the same thing, but backwards. While the array at the right pointer +1 is less than the subarray max, and the right pointer is less than the array length -1, we need to increment the right pointer. And yeah, I think that should do it. And then finally, at the bottom, what we want to return here is a length, right? So we'll have a window, which will be the right pointer minus the left pointer. And then because it's length and not indexes, and these pointers are representing indexes, we're going to want to return the right pointer minus the left pointer +1, because that's going to help to denote, not help to, but it's actually going to be representative of the length rather than the two indices that we have. And I think that is everything. Okay, so let's run this and we'll see what we get and debug if we have to. All right, so we get 5, 3, 0, 4, and 8. Okay, good. It looks like we are in a good spot. We got everything we expected. So yeah, I think, again, this is definitely a harder problem. But once you know the pattern and once you can kind of modify the pattern to fit the problem, the code itself is very simple. It is it's straightforward. It's a few while loops, and the time complexity of this is going to be big O of x, because at most we're only ever going through the array one time. We might go through the array, a few times in the while loops, but remember that if you go through an array 4 times, but it's not nested, you can drop that constant and it's still just a big O of x, right? So this is just a big O of x. We only ever are looking at the elements in each loop one time. And yeah, I thought this was a really cool use of this pattern. And honestly, one I'm not sure what I would do if I was trying to solve this naively. So yeah, I hope everyone enjoyed this, and that's about it for today. That's a wrap, people. We are done with the 2 pointers at either end of the array. And please join us next time. We are going to be starting a brand new little mini series all about 2 pointers at moving at different speeds, which is, kind of a similar pattern, but, kind of a different pattern. So I hope you all enjoyed this, and I hope everyone is having a great year. It's snowing. I'm visiting my parents, and it's all nice and wintry outside. So I hope everyone has a chance to take a break, go take a walk, enjoy nature, and enjoy all those other things outside of coding. But if you are, coding all day, all night, coding on the mind, interviewing, I also wish you well and hope that these videos are helping your journey. And I have nothing else of value to say today. So I will see you all in the next one. Take care. Bye, everybody.